Hello children, welcome to our tuition classes. Okay, we are going to do 10th standard physics, ICSE, okay? The first chapter force and not the C part of it, okay? What is that? Uniform circular motion. So we're going to see what you mean by uniform circular motion. This is the C part of that chapter, okay? Now let's see here, children. I'll just try to explain it to you. Very simple means very simple, children. Suppose, let me say like this. Along a straight road, if a person is walking, and please have a look here, in every 10 seconds, he is completing, or every 1 second, he is able to walk 5 meters. Every 1 second, from here till here, 1 second it goes, okay? It takes from here till here, from A to B to reach, okay? It has taken him 1 second. And how much is this? 1 meter. Again, from B to C, it has taken him again 1 second better. 1 second, okay? And how much is this distance? Again, 5 meter. Got it? So suppose C to D, if this person goes, okay? And again, how much time has he taken? 1 second, okay? And this distance is again 5 meter. So what I can say is every 1 second is walking 5 meters. That means this person is walking with a uniform speed. He is going with a uniform speed. Are you getting me here? Actually, this motion is along a straight line. So I call it as a linear motion. What it is? Linear motion with a uniform speed. I use the word linear motion as a uniform speed. Okay. The velocity is what? Z. Velocity. What is the velocity meter? You can see 5 meter per second. Speed is same 5 meter per second. But acceleration is zero because when acceleration takes place, when there is a change in velocity, but the velocity is not changing at all. The velocity remains the same. Now, velocity can change, okay? Velocity changes when two things, please have a look here. The speed, if speed changes, I can say velocity changes. Or if direction changes, I can say speed remains constant, okay? Direction changes, still the velocity is changing, or both of them are changing, velocity changes, I can say, okay? I hope you're understanding me here. See here, speed is changing. So I say velocity is changing, or speed remains constant. And here, speed changes, direction constant, direction same. Here, direction changes, speed constant. Okay, speed constant. So you can see here, when is velocity set to change? Okay, I'm writing the way I just give an heading to help you understand, children. So just remember, velocity changes kabhi bolte hain when the speed changes, but direction remains the same. Like in first 1 second, he walks 5 meters. Another 1 second, he walks 10 meters. Another 1 second, he just walks 3 meters. That means he's not walking equal distance in equal interval of time. So here, his speed is changing, I can say. But the direction remains the same. But I'll say the velocity is changing. This is one example. Or another example. Got it? The direction keeps changing. The person is changing the direction. One time he walks to the left, another time he walks to the right, he walks to the left. But his speed is constant. He's walking 5 meters per second only. Hey, I'll say velocity is changing. So when is velocity set to change? Velocity is set to change, okay, in two cases. When speed changes, direction remains the same. I say velocity changes. Or direction changes, velocity, speed remains the same. I say velocity changes. Or when both are changing, of course, okay? Okay, children. Now, I want to come to uniform circular motion. The word uniform has come. Got it? It speaks a lot. Suppose a person is walking along a circular path. A person is walking along a circular path. I'll say a circular path, okay? Like I'll make a path. Listen. Okay. Okay, children. This is a circle, okay? And he walks along the circular path, okay? That means he walks along the circular path. He walks along the circumference, okay? He walks. And what I realized, he is walking here also exactly 5 meters in 1 second. Again, 5 meters in 1 second. Again, 5 meters in 1 second. That means he is walking with a uniform speed. The speed is constant. But what do you see in a children? Beta, at every point, his direction keeps changing. Suppose he is at position A. If you ask me what is the direction of motion, I'll say his direction of motion is along this tangent line. Okay, along this tangent line. What is tangent line? You learned it in geometry. A line which touches a circle at one point. So if I say he is here, what is the direction of motion? The direction of motion will be along the tangent line. So I draw a tangent line at this point. Okay, if the person is at point, some other point, okay, when you see here, is here. Okay, the person is here. The person is here. Again, if you ask me what is the direction of this person, I'll just draw a tangent line at that point. So what do you see? He was walking just 5 meters per second along the circumference. That means he had a uniform speed. But his direction keeps changing. His direction keeps changing. Now, such a motion, we along the circle, got it? With a uniform speed, we call it as uniform circular motion. I'm not using the word, I'm not going to tell anything about direction right now, but I say, what is uniform circular motion? Motion of a body along the circular path with the uniform speed is called uniform circular motion. Got it? Motion of a body, I'll tell you, what is uniform circular motion? Okay, they just ask, what is uniform circular motion? So motion of a body along the circular path, along the circular path with a uniform speed, is called uniform circular motion. But this uniform circular motion, when you further try to find facts, what do you get revealed? Just a uniform circular motion. Okay, you understood? Very simple. Uniform word is there, the uniform speed hai. Circular word is there, that is along the circular path hai. Motion, beta kitna easy hai. Motion of a body along the circular path with uniform speed is called uniform circular motion. But we found out some other facts. At every point on the circular path, the direction of the body keeps changing. Hence, I cannot call it as a uniform speed, but I call it as a variable velocity. The body is moving at a variable velocity in a circular path. Got it? When I say in terms of velocity, I cannot use the word uniform velocity. Got it? The body is moving at a uniform speed along a circular path, but with a variable velocity. Why? The direction keeps changing. The magnitude of the velocity will remain the same, but the direction keeps changing. So naturally, in a uniform circular motion, for a body, please have a look here. For a body having uniform circular motion, for a body having uniform circular motion, the velocity is variable because at every point in its path, the direction of motion is changing. Got it? So remember, for a body having uniform circular motion, The velocity is variable. Why? Because at every point in the path, at every point in its path, the direction of the motion is changing. I just now showed you. Okay, how do you get the direction of motion? I told you to get a motion, direction of motion, just draw a tangent at that point. The direction of motion is along a tangent line. So in a circular path, the direction of motion is obtained by the tangent line at that point. Okay, so I'm going to write that now. So please have a look here. I'll just say in a uniform circular motion, in a uniform circular motion, in a uniform circular motion, the direction of the motion at any point on the circular path is along in a uniform circular motion, the direction of motion at any point on the circular path is along the tangent to the circular path, at that point. Okay. Now, one more thing, children, please keep it in mind. When the velocity is changing, that time we say the body is having an accelerated motion. If the velocity is not changing, the velocity is not variable, the body is not having an accelerated motion. Like along a straight line path, it was going at the uniform speed. The acceleration was zero. The body didn't have any acceleration. Now, along the circular path, the direction of the acceleration is also changing. Got it? Timing. Please have a look here. The direction of the velocity is changing, at every point. That means it's having a variable velocity. Even the direction of the acceleration is changing. It will be also a variable acceleration. Got it? But this motion, uniform circular motion, is an accelerated motion. Uniform circular motion is an accelerated motion. Got it? Even the word uniform comes, but it is an accelerated motion. But why? Because the velocity the body is having in a uniform circular motion, the velocity of the body is variable. Hence, it has an accelerated motion. I hope people are getting me here. So please see it. I'll just write it down. In a uniform circular motion, the body move. Okay, I'll just rub it off and then write it down, children. For a body having uniform circular motion, okay, I'll write it here. Okay, for a body, please here, I'll just write it out. For a body having uniform circular motion, for a body having uniform circular motion, the velocity is variable. Velocity is variable. Because why variable? Because the direction of motion keeps changing. The velocity is variable. Hence, it is said to be an accelerated motion. It is said to be an accelerated motion. It's said to be an accelerated motion. So keep in your mind better. This uniform circular motion is an accelerated motion. Uniform circular motion is an accelerated motion. I hope people are getting me here. Now just go ahead, children. Okay. Now listen, people can always ask you, what is the difference between a linear motion and uniform circular motion. What is the difference between a uniform linear motion and uniform circular motion? Uniform linear motion. Okay, what is it? Please have a look here. What is the difference between uniform linear motion and uniform circular motion? What is the difference between uniform circular motion? What is the difference between uniform linear motion and uniform circular motion? Okay, so I'll just say like this. In a uniform linear motion, if a body moves along a straight line path with a uniform speed, then it is said to have uniform linear motion, okay? Linear motion. Now, what is the uniform circular motion, children? Beta, just have a look here. I'll put it like this. If a body moves along, a circular path, with a uniform speed, okay, then if a body moves along a circular path, with a uniform speed, then the body is said to have a uniform circular motion. Body is said to have a uniform circular motion, children. Okay, then beta, just have a look here. Body having uniform linear motion, the velocity is uniform. For a body having uniform linear motion, the velocity of the body is also said to be uniform. Got it, children? Uniform. Now, for a body, second one, okay? For a body having uniform circular motion, for a body having uniform circular motion, for a body having uniform circular motion, what I can see, the velocity of the body is said to be variable because the direction of the motion keeps changing. Is said to be variable. Got it? Is said to be variable because the direction of its motion keeps changing. Keeps changing. Got it? Now listen, when the velocity is uniform, naturally there is no acceleration, children. So uniform linear motion is not an accelerated motion. Matlab acceleration zero है accelerated motion because velocity change नहीं हो रहा है ना. Okay, yo, the velocity is variable. I'm not asking you to measure acceleration. When you try to measure acceleration, it will be zero perhaps. Uniform circular motion में velocity acceleration may be zero. Magnitude of the acceleration will be zero. But still, this is called an accelerated motion because the direct velocity is changing. Velocity, because the direction is keeping on changing. So uniform circular motion is an accelerated motion. Is an accelerated motion. Okay, children. I hope people have understood this. Not everybody must have got an idea about uniform circular motion. Okay. Now we go ahead. Okay. We go to the next part of this topic. Now, what do you mean by children? Centripetal force. Something very interesting and very easy, children. Try to understand this, okay? So, very easy, children. Very easy means very easy, okay? So, what is that? What do you mean by centripetal force? So, let me see an example, okay? Like, suppose somebody is ahead of you. You both are walking, okay? Both are walking, and the person who is ahead of you, okay, is not giving you, both are walking on a narrow path, okay? Two of you are walking along a narrow path. You is walking here, like you're A and you're walking here, and this person B is walking ahead of you. Both are walking, okay? Both are going towards the west, okay? I better say like this, okay? Now, both are, sorry, towards the east. Okay, both are walking towards the east. Now look here. This person A is walking fast, person B is walking slow. So naturally, this person A, since is walking fast, he will overtake B. Got it? But this is such a narrow path, children. Got it? So what he'll have to do? He will have to push this B person a little. When he pushes, what will happen, beta? He'll change his direction a little. And when he changes his direction, then A gets little place to supersede him, going ahead of him. Got it? A will get time space. That means I'll put it like this. The direction of motion of B got changed because A applied a force. Then somebody will say, ऐसा काय को करने का? वो बोलता था ना नजदीक ए बाजू और जाता था. चलो ना आप ऐसा बोलेंगे तो मैं बोलूंगा अरे बी इज डेफ बाजू बोलेगा तो भी सुनेगा नहीं तो क्या करे? Naturally has to apply a force and move him aside. So remember, for changing the direction, I'm interested in only one thing, children. I must have given a useless example, but I'm interested in telling you only one thing. For changing the direction of motion, a force is essential. Got it? For changing the direction of motion, a force is essential. Got it? If no force acts, then no change in direction will take place. For changing, please here, for changing the direction of motion, changing the direction of motion, a force has to be applied. A force has to be applied. So this is one of the effects of force also. Changes the direction of motion, okay? So for changing the direction of motion, a force has to be applied. Remember this, like a property. If you want to change the direction of motion, a force has to get exerted, okay? Now what I'm trying to tell you, keeping this in mind, in a circular path, what do you see, beta? In a circular path, the direction keeps on changing. Suppose a body is here at this point. Suddenly it has come here. At every point, the direction keeps changing. But in a circular motion, in a uniform circular motion, a direction, the direction of motion keeps changing. The direction of motion keeps changing. Hence, don't you realize? But a change in direction can be brought about only by a force. That means here in a uniform circular motion, the direction of motion keeps changing. Hence, constantly a force is acting on it on it, which is changing its direction, which is changing the direction of motion, which is changing the direction of motion. This force, please keep in your mind, this force is called a centripetal force, is called centripetal force and it is always directed towards the center of the path, towards the center of the path, okay? But listen, one thing, but the centripetal force kahan se aata hai bhai? I know, I understand, centripetal force gets exerted on these bodies, but ये source क्या है? How? Automatically aata hai? Nahin beta. There has to be some scientific reasons for the source, for the origination of centripetal force to come into existence. There has to be some reason. So what is that? Let's try to understand. So what is centripetal force, beta? Centripetal force is the force which is responsible for the uniform circular motion. And it is always directed towards the center of the path, circular path. I hope people understand me here. Now let's go one step ahead to understand. Like examples may, you see how this centripetal force comes. Correct. So please have a look here. Suppose in a in a nucleus, okay, we said, please have a look here. Somewhere in an atom, I'm sorry, there's a centrally placed nucleus and the electrons revolve around the orbits. And this electron, if you go to see beta, is having a uniform circular motion. So why uniform circular? That means a centripetal force is acting. So where is the centripetal force? It's nothing but the electrostatic force of attraction between the protons, positively charged protons present inside the nucleus and the negatively charged electron. There is a force of attraction. That force of attraction is nothing but, I can call it as a centripetal force. And that centripetal force keeps acting on this electron. Hence, this electron keeps moving along the circular path. So it's having a uniform circular motion. In the same way, suppose all the planets revolve around the sun in an orbit. So don't you realize, constantly at every planet, a centripetal force, a planet, it is revolving around the earth, sun. Okay, it revolves around the sun. It revolves around the sun. So why it revolves around the sun? That means it is having a uniform circular motion. Why it is having a uniform circular motion? That means there is a centripetal force acting. अरे लेकिन किधर से आता है centripetal force? There is, a sun is so huge that it exerts a gravitational force of attraction on the planet. This gravitational force of attraction is nothing but a centripetal force here. Are you getting me? And that keeps on changing. That changes the direction of motion of the planet. And the planet is said to have a uniform circular motion. In the same way, when you see, the moon is a satellite of Earth. The moon revolves around an orbit. So this moon is having a uniform circular motion. So uniform circular motion kaisa aayega moon se? So naturally, I'll tell you, please here, there is a centripetal force constantly acting on the moon. Lekin kaisa? Yes, the gravitation, force of gravitation. Got it? That is a force of gravity exerted by the earth on the moon. Got it? Becomes a centripetal force and it keeps it changing the direction of motion of the moon. The moon is having a uniform circular motion. In the same way, suppose you take a string and tie one stone at one end of the string and you revolve it, whirl it. Okay, you start one end of the other end of the string. Okay, you hold it in your hand and start
what you can say, you whirl it, keep on whirling it, WHIRLING. So this, you're doing it, am I right? So this stone is performing a uniform circular motion. So the centripetal force is exerted by this string. There's a force of tension. There's a force of tension towards the center. Got it? There's a force of tension acting towards the center. Got it? That is your hand. Okay. And this stone keeps on moving, changing its direction. That is, it's having a uniform circular motion. Got it? But that centripetal force is acting, and that centripetal force का इधर source क्या है बेटा? The force of tension on the string. Okay, so I hope everybody has got an idea about centripetal force. So for the last time, a uniform circular motion, the direction of the motion of the body keeps on changing. That is due to the centripetal force constantly acting on it. This centripetal force is always directed towards the center. Now, children, we go to another type of force. Now we go to another type of force called centrifugal force. Now, what is the centrifugal force? Just here, this is, you can call it as a merry-go-round, or just say rotating disc. Rotating disc. Disco mein rotating disc hota hai na? Okay. Now, to the center, you can see here, with the help of a string, a stone is tied. This disc is at rest. Is at rest. Okay. And this stone is tied to a string, and the string is loose. Got it? Now, that is it tied to the center of this disc, or center of this merry-go-round. Got it? So, ये जो stone का thread है, okay, string है, वो थोड़ा loose है, आप देख सकते हैं. फिर एक observer P भी है बाहर. ये observer हो, आप खड़े हो इधर center में, आप देख रहे हो loose है, observer P भी देख रहा है. Okay. Now, this merry-go-round is rotated. It starts moving, uniform circular motion. So, first thing what the observer O will see, this string tightens itself. The string tightens itself. And he's just standing. And always, keep in mind, for him, always this stone is in front of him. For him, the stone is in front of him. The stone, even though this has started moving, but the stone is always in front of him. Okay, always, because he is also moving, facing the stone. Okay, facing this string and the stone, he is also moving, the observer. So always observer को लगता है stone उसके सामने ही है, even though a disc, ये merry-go-round घूम रहा है. Got it? Now what I'm trying to tell you. Suppose I cut this string. Suddenly it's moving, the string is cut. So what will happen, this person P, he sees the stone, and the stone is falling along a straight line. For him, the stone is falling along a straight line. It's moving, I should not say, is moving along a straight line like this. It's moving along a straight line. So I can imagine it to be, it is going in this direction. The stone is falling in this direction. When that string is cut, the stone tends to fall in this direction for this observer P. And it goes along a tangent line. It goes along a tangent line. You can imagine tangent to this path, okay, at this point. Tangent line. But for this observer P, उसको दिख रहा है stone along a straight line ऐसा गिर रहा है along a tangent line to the circular path. But to this observer P, I told you this disc is moving. Disc तो continue move हो रहा है. तो ये क्या देखेगा? ये हमेशा observer O dash इधर है. तो ये जो stone है, stone भी इसका position उसका सामने ही है. Again थोड़ा और इधर आएगा O double dash. उसका सामने ये स्टोन जैसा मूव हो रहा है, तो ये स्टोन उसको क्या लगेगा कि स्टोन लंबा लंबा जा रहा है, लेकिन उसका सामने ही जा रहा है. It is in front of him, only it's going away from him. Because he's facing the stone appears as if it's going along a straight line away from the center. Are you getting me here? So why is it going away from the center? So to explain this motion, we are assuming there must be a force which is pulling it away. Pulling it away. I hope children, you are understanding, you are able to imagine what I'm saying. Very simple. For this here, this once again I'll repeat. This is a circular disc. Disco ka disc. Center में एक pole है समझो. Okay. Now there is a string tied to, and to one end of this string, stone is tied. The other end of the string is tied to the center of the, what you can say, disc. Now what you see, the stone, the thread is loose. Okay. Now it's, and one person P is standing outside. He also keeps looking at the stone. Now you start moving this disc or merry-go-round. You start moving it in a circular motion. So it's having a uniform circular motion. That time, this observer, he keeps seeing that the stone is always in front of him. Only thing, this rope string has tightened up. Now, why the string is tightened up? It's because of the force of tension. Force of tension towards the center. A force of tension makes it straight. अभी suddenly गोल घूम रहा है string, this disc. I cut this string. When I cut this string, what happens to this observer P? The stone is falling along a straight line. टक करके गिर जाएगा along a straight line. We say it's falling along a tangent line. But ये जो P वाला observer है, वो हमेशा उसका stone सामने था, घूम रहा है. So he is just standing straight and the stone was always in front of him. So now when he cuts, what he sees, the stone is again in front of him only, but it's going away from him. It's going away from him. जैसे इधर देखो O उसका सामने है, स्टोन इधर फर्स्ट पोजीशन में आया, तो O डैश उसका पोजीशन उसका सामने ही है. Then स्टोन सेकंड पोजीशन में आया, O डबल डैश उसका भी पोजीशन है, सामने ही है उसका. Got it? तो हमेशा उसका सामने ही दिखता है. Now why? So he's thinking it's going away from me. So to explain this motion, अरे for that observer वो लंबा लंबा जा रहा है stone, उसका सामने ही लेकिन लंबा लंबा जा रहा है. That means there is some force acting away from the center. And this force, they called it as centrifugal force. Actually, just centrifugal force is said to be equal in magnitude to the centripetal force. Centrifugal force is said to be equal in magnitude, okay, to the centripetal force, and opposite in direction. But that means some people may say it's action-reaction forces. Nay, action-reaction forces, they always act on two different bodies. Here, this both centripetal and centrifugal force are acting on the same body. So they cannot be action-reaction forces. But this centrifugal force is said to be equal in magnitude to centripetal force and opposite in direction. Got it? It is away, going away from center of the circular path. You understand? But this force is it a real force? See, it cannot be a real force. It is a pseudo force. It is a pseudo force, not a real force, Now, what does it mean? It is why pseudo force, not a real force? Because we are talking about this because see, a motion, we have learned like this, a motion is brought about due to a force. And since this body, for this observer only, observer standing at the center, this body was going away from him. So when it is going away from him, naturally in a straight line, some force is pulling it. Got it? So only to explain this motion, away motion, they said there is a force which is pulling it, and they called it a centrifugal force. So just to explain a motion, this force has been assumed. Hence it is called, इसका source नहीं है. Hence it is called a, what you can say, pseudo force, not a real force. I hope people are understanding me here. Got it? See here, it is going away from the center of circular path. It is a pseudo force. Okay? Because why? Because it has been assumed for a particular motion, for a particular motion, taking place, okay? But actually, there is no force at all. But we have, just to explain that particular force, I mean motion, going away from the observer, this was centrifugal force was named. I hope people understood me here. What is the centripetal force? Okay, just a pseudo force. It's not a real force. It is a fictitious force. Okay, pseudo force or fictitious force. They also call it as fictitious force. Are you getting me here? Because actually, इन्होंने खाली assume किया ऐसा force है because to explain one particular motion. Got it? Motion. Okay, children. I hope people are understood about this centrifugal force. So with this beta, this chapter force comes to an end. Okay, children. Then see you all till then. Bye, children. Bye, bye, bye.